Okay, so here is a video lesson describing how to calculate molar mass. So get your periodic table out, get a calculator, and follow along. You should have a worksheet that has a bunch of questions on it, and I'm going to solve through some of them and then give you answers. Now, you're going to use your periodic table like this. Okay, if you look at the periodic table, the element is described, so we have the atomic symbol, we have the actual name of the element, we have the atomic number, that is the number of protons, and then here we have the average atomic mass. So this is the number we're going to be using. When we calculate molar mass, I'll write this out, molar mass, that is the mass of 1 mole of the atom or element. So it's going to be in units of grams per mole. And we're going to get that number from, so for oxygen, the molar mass is 15.9994. And for nitrogen, it is 14.00674. And we won't be using all those decimal places. 2 will be fine for us. So that's what you're going to be doing. Let's take a look at the next page. So here we go with the worksheet that you'll be doing, and I'm going to solve them through for you. Question asks, find the molar masses of the following compounds. So here we have NaBr, or sodium bromide, okay? And if you look at the periodic table, the elements are Na sodium and Br bromine. So what we have is we have 1 sodium atom, and the molar mass, if you look at sodium, if you look at sodium, we have 22.99. So we have 22.99, that is grams per mole. And then plus, for the bromine atom, 79.90. 79.90. And you get out your calculator and add those two together. So I am, this calculator doesn't have batteries. Nice work. Hold on a moment. Okay, I'm back with a calculator that works. 22.99 plus 79.90 equals, we got 102.89. 102.89. And this is going to be in grams per mole. Grams per mole. So 102.9 grams is actually a bunch. That's the weight of, like a little stack of paper, or maybe one of those spiral notebooks. Okay, and a mole of these atoms would be a lot. Again, a mole, similar to a dozen, only it's a huge number. 6.02 times 10 to the 23rd, so 23 zeros. Next up, PbSO4. This is lead sulfate. And so for some of these, I'll be describing what the actual this ion has an actual name, and that's the sulfate ion, and we'll get to that later. But for now, all you need to know is that we look on the periodic table for lead, Pb, and where did that go? Pb. Alright, so I'm feeling a little blind right now. Not PD. PT. Oh, this is embarrassing. It is, I must have a faulty periodic table here. Aha, there it is. So Pb, atomic number 82, it has an atomic mass of 207.2. So for lead, we have 207.2. And again, that was for this atom. Then we have S, the sulfur atom, and periodic table says that is 32.065. So in rounding, 32.07. We're using 2 decimal places for these. Okay, and this is just a little, don't worry about that. Next is O4. So this means we have 4 oxygen atoms. So watch the way I write this. 4 times, and whatever the atomic mass of, or molecular mass, excuse me, of oxygen is. So 15.999, which would round to 16.0. Actually 16.00. We're using 2 decimal places. And plugging this all into the calculator would give, let's see, clear, 207.2 plus 32.07 plus 4 times 16.00. Whoops. Equals, looks like 123.27. 123.27, and this is grams per mole. Now, if you wanted to, it depends on what calculator you're using, and very soon, well, this, you could do a separate step where you multiply 4 by 16 right off the bat, and so that would give 64, so that you're adding this plus 64. Okay, that may be easier. Next example, number 3, calcium, and then this, the OH, is called the hydroxide ion, and we have 2 of them. So it's going to be a calcium, 2 oxygens, plus 2 hydrogens. Periodic table says calcium 40.08. Notice how I rounded there. So for calcium, what did I say? 40.08 plus, and 2 oxygens. 2, notice how the O, this is sort of like math. Don't freak out, but yes, it's sort of like math. Notice how the O is in the parentheses, so there's 2 oxygens and 2 hydrogens. Okay. And 2 oxygens, the oxygen again was 16.00 plus, and 2 of the hydrogens, periodic table says 1.0079. So rounding that to 2 decimal places would give, you guessed it, 1.01. Okay, calculator. 40.08 plus 2 times 16, which is 32, plus 2 times 1.01, which would be 2.02, 2.02, and we get 74.1, and this is grams per mole. Alright, so it looks like you're getting the hang, whoops. Hopefully you're getting the hang of this. Let's see if I can, yep, erase. This is good. I'm going to do, let's see, yeah, let's do this one, number 7. So you're going to do number 4 and number 5 and number 6. And on the next page, I have the answers to all of them listed. Hopefully we got these right. Let's take a look at number 7, okay, because this is a little tricky with the parentheses and the numbers and the numbers. So Fe3, this would be like a ferric phosphate is what this would be called. Iron sometimes has the name ferric or ferrous. So Fe3, iron on the periodic table, 55.85. So we have a 3 times 55.85 plus. Now take a look. The P, not potassium, K is potassium. The phosphorus atom is inside this parentheses with a 2 out front. So there are 2 phosphoruses. But then look at the oxygens. This is O4 in parentheses, so there's 2 O4s, meaning 8 total oxygen atoms. So there's going to be 8 oxygen atoms. Okay. So what do we do? 2 times the atomic mass of phosphorus, 30.97, plus, and there are 8 oxygens. Again, we got that from the 2 times the 4. So 8 oxygen, 16.00. Calculator says, let us see, 3 times 55.85 plus 2, no, that's a 3, 2 times 30.97 plus 8 times 16. Alright, equals, let's see, need a little space, equals 357.49 grams per mole. Okay, so I'm going to leave the rest up to you to solve. And you're writing these on your paper. You're going to turn these in. And on the next page, I'll show you the answers. And let's write down, I just want to verify that ours are correct, because there may be some rounding differences, which isn't a big deal. But for, let's see, 1, we got, so I'm writing this down on my paper just to check, 102.89 grams per mole. Number 2, we got a 123.27. Number 3, what did we get? Oh, that got kind of messed up, but whatever. I think I can read it. Looks like 3 was a 74.1, and then the other one we did was 7, which was 357.49. Okay, let's take a look at the next page with answers. And 1 is 102.9, all right. 2 is 303.3, so that looks totally different. 3 is 74.1, and 7 is 357.4. All right, so these answers look like they're rounded to just one decimal place. All right, and I think I'm going to go back and take a look at number 2 and probably have to create a separate video. So I probably made a mistake somewhere, unless these answers are wrong. So take it from there, see if you can solve the rest, and we'll get back in a second video.